अस्सलाम वालेकुम स्टूडेंट्स। अब हम चैप्टर नंबर 6 परमुटेशन जो फर्स्ट ईयर का मैथमेटिक्स है, चैप्टर 6 परमुटेशन कम्बिनेशन एंड प्रोबेबिलिटी, क्लास 11। तो इसका जो एक्सरसाइज 6.4 है दैट इज़ अबाउट द प्रोबेबिलिटी and all related things. So to solve this exercise, first we need to define and learn sample space and event, because we are going to use these two things in the exercise. So what is a sample space? The set of all possible outcomes of a random experiment is called a sample space and is denoted by S. अगर हम कोई एक्सपेरिमेंट करते हैं तो जितने पॉसिबल आउटकम्स हैं, तो उन सब आउटकम्स को अगर हम एक सेट के अंदर लिखते हैं तो उस सेट को हम सैम्पल स्पेस कहते हैं। ठीक है। फॉर एग्जांपल टॉसिंग कॉइन, अगर हम एक कॉइन को टॉस करते हैं तो उसके जो पॉसिबल आउटकम्स है या हेड होता है या टेल। तो हेड और टेल को अगर हम एक सेट के अंदर लिख लें तो इस सेट को हम सैम्पल स्पेस कहते हैं, बिकॉज दीज आर ऑल द पॉसिबल आउटकम्स। इसके अलावा इस एक्सपेरिमेंट का कोई रिज़ल्ट नहीं हो सकता। ठीक है। अच्छा, इसके बाद है इवेंट। लेट एस बी ए सैम्पल स्पेस ऑफ एन एक्सपेरिमेंट एनी सबसेट ऑफ ई ऑफ एस। सैम्पल स्पेस का कोई सबसेट होता है ई, उसको हम इवेंट कहते हैं। इज कॉल्ड एन इवेंट एसोसिएटेड विद द एक्सपेरिमेंट। जब आपके पास सैम्पल स्पेस आ जाए तो उसके बाद आप किसी एक इवेंट की प्रोबेबिलिटी फाइंड करते हैं। ठीक है। और वो इवेंट क्या होता है? वो सैम्पल स्पेस का सबसेट होता है। यानी एक इवेंट जो है ना, सैम्पल स्पेस का एक पोर्शन होता है, एक हिस्सा होता है। ठीक है। तो इसकी एग्जांपल क्या है? फॉर एग्जांपल ई इज़ एन इवेंट विच हैज़ एच एच टी टी, यानी एच इज़ फॉर हेड एंड टी इज़ फॉर टेल, इज़ एन इवेंट एसोसिएटेड विद द एक्सपेरिमेंट ऑफ टॉसिंग ए कॉइन ट्वाइस। जब हम एक कॉइन को 2 दफ़ा टॉस करते हैं तो हमारे पास जो सैम्पल स्पेस बनेगा उसमें कितने एलिमेंट्स होंगे? 4 एलिमेंट्स होंगे। एक्सक्यूज़ मी, क्योंकि उसके में हमारे पास एच टी, अगर मैं यहाँ पे सैम्पल स्पेस दोबारा लिख लूँ, सैम्पल स्पेस हमारे पास हो जाएगा एच एच, एच टी एच और टी टी। ठीक है। दीज आर ऑल द पॉसिबल आउटकम्स इफ़ वी टॉस ए कॉइन ट्वाइस। ठीक है। तो इसका जो फार्मूला है हमारे पास सैम्पल स्पेस का, वो हमारे पास है 2 पावर n, और हमने 2 दफ़ा कॉइन को टॉस किया है तो 2 पावर 2, और इससे हमारे पास क्या आ जाएगा? 4। ठीक है। क्योंकि एक दफ़ा कॉइन को टॉस करने में हमारे पास जो सैम्पल स्पेस बनेगा वो 2, और 2 दफ़ा कॉइन को टॉस करने से हमारे पास सैम्पल स्पेस 4 बन जाएगा। अगर हम 3 दफ़ा कॉइन को टॉस करेंगे तो 2 पावर 3 विच इज़ इक्वल टू 8। ठीक है। इस तरीके से ये बढ़ता जाएगा। अच्छा, अब ये सारी चीज़ें हमने इस एक्सरसाइज में यूज़ करनी है। क्वेश्चन फर्स्ट में कहते हैं लेट एस बी 1 2 3 4 5 6 बी ए सैम्पल स्पेस ऑफ रोलिंग ए डाई। अगर हम एक डाई को रोल करते हैं तो व्हाट इज़ द प्रोबेबिलिटी ऑफ रोलिंग ए 5, रोलिंग ए नंबर लेस देन 1, रोलिंग ए नंबर ग्रेटर देन 0, रोलिंग ए मल्टीपल ऑफ 3, रोलिंग ए नंबर ग्रेटर देन और इक्वल टू 4। ठीक है। तो फर्स्ट पार्ट में हमारे पास जो सैम्पल स्पेस है, सैम्पल स्पेस सेम रहेगा, जो इसमें 6 एलिमेंट्स हैं। Part first, S is 1 2 3 4 5 6. Number of element in S is equal to 6. Now come to event. Event is rolling a 5. Okay, so how many elements are there in event? Only 1. So number of element in event is equal to 1. Now formula of the probability is probability of occurring this event is equal to number of element in this event divided by number of element in whole sample space. So number of element in this event is equal to 1 and number of element in whole sample space is 6. So 1 over 6. So it means that if we roll a die, so the probability of getting 5 is 1 over 6. Okay, now come to part, this is part 1, part 2, rolling a number less than 1. So rolling a number less than 1 is rolling a number less than 1, because there is no 0 in this one, because a number less than 1 is obviously 0, but we don't have any 0 over here. It means that this event has no element, so the number of elements in the set of event is 0, right? So number of element in event is equal to 0, so the probability of occurring this event is equal to P of E is equal to number of element in E divided by number of element in sample space, and elements in this event is 0, so 0 by 6 is 0, so there is no chance of getting a number less than 1, right, if we roll a die. So the probability of getting a number less than 1 is 0. Okay, now come to part 3. Okay, so in part 3 we are going to find the probability of event which is rolling a number greater than 0. So first we are going to write the number of elements in this event, which is, so we are going to check how many elements are greater than 0 in this sample space. So we can see over here in this set that every element in this set is greater than 0. So it means that we are going to write all the sample space in this event, which is 1, 2, 3, 4, 5, 6, right? And number of element in this event is equal to 6, and we already know that number of element in sample space is also 6. Okay, so the probability of getting a number greater than 0 is certain, means that we will definitely get a number greater than 0 if we roll a die. So the probability of this event is equal to number of element in the event divided by number of element in sample space, which is equal to 6 divided by 6, which is equal to 1. It means when we get 1 in the probability, it means that we are certainly getting this thing, like there is no doubt that we will not get this thing, right? So that is the probability of rolling a number greater than 0. Now come to part 4, which is rolling a multiple of 3. So first we are going to write the number of element in E. So how many multiples of 3 we have? Multiple of 3, rolling a multiple of 3, right? So we will have 3 and 6, because these two are the only multiple of 3 in the sample space. So how many elements we will have? Just 2 elements. Okay, so probability of getting these two number is equal to P of E is equal to number of element in E divided by number of element in S, which is equal to 2 by 6, which is equal to 1 by 3. So there are 1 over 3 chances that we will get these two elements if we roll a die. Now part 5, rolling a number greater than or equal to 4. So first we are going to write the event in the event. So rolling a number greater than or equal to 4, so it will be either 4 or greater than 4. So 4, 5, 6, right? So it means that what is the probability that if we roll a die and we will get a number 4 or greater than 4, which is only 5 and 6. So we are talking about only 4, 5, 6. The number of element in this event is equal to 3, and the probability of E is equal to number of element in E divided by number of element in sample space, which is equal to 3 by 6, which is equal to 1 by 2. It means there are 50% chances that we will get either 4 or 5, 6, right? So that was all about question number 1. Now come to question 2. Okay, in question number 2, a bag contains 4 white balls, 5 red and 6 green balls. 3 balls are drawn at random. what is the probability that all are green balls are, and the second one is all are white balls. So we are going to find that what is the probability that the 3 ball drawn are all green balls. So for that, first we have to write the number of element in sample space, right? So number of element in sample space is how many? 4 white, 5 red and 6 green. So we have all 15 balls, right? So now what is the probability that the 3 ball drawn are all green balls? So part 1, the probability of getting first ball that would be green is 1 by 15. So we will write probability of 3 balls drawn are green, right, is equal to how many green ball we have altogether? 6 green ball. So 6 by 15, right? Because if somebody put his hand in the bag and he draws a ball, so the probability that the first ball drawn is 6 by 15, that ball will be green ball, okay? And now if the second ball drawn is green, so the second ball, if we are talking about the probability of green ball, so there would be one less green ball left in the bag, so that will be 5, and the sample space will become 14 because one ball has already been drawn, so that will be 5 by 14, right? And if the third ball will also be a green ball, so it means that there is already two green ball drawn, right? So how many green ball left in the bag? That will be 4, and the sample space will decrease to 13 because 2 ball has already been drawn. So that is the probability of getting 3 green balls, right? And for your convenience, you can also write how many white ball are 4, white balls are 4 and red ball are 5 and green are 6. Green ball is equal to 6. So if we multiply all of them, we will get 6 by 15, 5 by 14 and 4 by 13. So 5 3s are and 3 7s are, right? And we will have 3 4s are 12, and we can also cancel this 3 with this one, so we will get 4 divided by 91. So the chances of getting 3 green ball is 4 out of 91, right? So that is the probability of getting 3 green balls. Now if the 3 ball drawn are all white, so what will be the probability of that, right? So we will write probability of drawing 3 white balls. The probability of getting first white ball is, how many white ball do we have? 4. So it will be 4 by 15, and for the second ball there will be one less white ball in the bag, so that will be 3 divided by 14 because the sample space will also decrease to 14. And for the third white ball, because 3 white ball has have already been drawn, so we will have 2 and sample space will decrease to 13, right? So 4 by 15, 3 by 14 and 2 by 13. So 3 1s are 3, 5s are 2, 7s are, and that's it. 4 divided by it will be 91 times 5, So 455. So that is the probability of getting 3 white balls from the bag, which has 15 balls altogether. Okay, so if you have any question, you can ask me. Okay, so that's not very difficult. You just have to remember that you have to multiply them, because getting 3 balls consecutively, the probability will decrease, because the probability of getting first white ball is like 6 by 15, which is much more than this one. But the second, if we are talking about the drawing the second white ball, sorry, green ball in this case as well, so that second ball will decrease the probability, and third green ball will further decrease the probability, right? So that was all about this question number 2. Now come to question number 3. In question number 3, excuse me, a true false test contains 8 questions. If a student guess the answers, right? So find the probability that 8 answers are correct. So to solve this question, for all these parts, we have to write the sample space first, right? So for every question we have 2 choices, true or false, true or false. So how many choices do we have altogether? 256. We have to multiply 2 8 times, so 2 power 8, which is equal to 256. Okay, the first question, 8 answers are correct. Okay, so for that, part number 1, E is equal to 8 questions are correct. We have 8 combination 8. It means that 8 answers are correct out of 8 questions, right? So we have 8 by 8 using the same formula of combination. We have 8 factorial divided by 8 factorial and 8 minus 8 factorial, right? Basically the formula is n combination r, n factorial, r factorial, n minus r factorial. Okay, so we have 8 by 8 is cancelled, so we or you can write 8 factorial divided by 8 factorial and then 0 factorial. This is cancelled and 0 factorial is 1, so we just have 1. So the number of element in this event is equal to 1 only. Okay, so now the probability of getting 8 question correct is probability of E is equal to number of element in E divided by number of element in S is equal to 1 divided by 256. So there are only 1 out of 256 chances that when a person guess the answer of each question, so he will have all the question. He will give the correct answer to all of the questions, and its chances are only 1 over 256, which is quite slim. Like, 1 out of 256 is, it's very less. It's like, it's less than 1% even. Okay, so 7 answers are correct and 1 is incorrect. For second question, we have sample space still the same 256 and event is 7 answers are correct and 1 is incorrect. Okay, so using the same combination formula, we have number of element in this event will be 7 combination 8. It means that 7 out of 8 will be correct, right? Sorry, it's, since this is n combination r, right, the total element has to be written on top, so it will be 8 combination 7, so which is equal to 8 factorial divided by 7 factorial and 8 minus 7 factorial, which is equal to 8 factorial divided by 7 factorial and 1 factorial. And we can write 8 factorial as 8 into 7 factorials to cancel this 7 in denominator. So we will have only 8 divided by 1 factorial is 1, right? So 8 by 1, and which is again equal to 8. So number of element in this event, this particular event is 8. Now the probability of getting this event is equal to number of element in the event divided by number of element in sample space, which is equal to 8 divided by 256, and which is equal to 1 by 32. So there are 1 over 32 chances. So these chances are quite more, like it's around 3% chances that the person will guess 7 answer correct and 1 answer incorrect. Okay, now come to part 3, which is 6 answers are correct and 2 are incorrect. So part number 3, the event is equal to 6 answers are correct, right? So we will have 8 combination 6. It means that 6 out of 8. So that will be 8 factorial, 6 factorial and 8 minus 6 factorial, which is equal to, we have to open this 8 up to 6 to cancel this one. So 8, 7, 6 factorial divided by 6 factorial and 2 factorial. This 6 is gone with this one, and you can cancel this 2 with this 4. So 4 7s are 28. 28. So number of element in this event is equal to 28. So we are going to find the probability of getting this event, which is equal to probability of E is equal to number of element in E divided by number of element in S, 22 divided by 256. So we will have 7 and divide by 4, so we will get 64. So there are 7 out of 64 chances that he will correct 6 answers, and the 2 remaining answer will be incorrect. Now the last part, that at least 6 answers are correct. So it means that for at least 6 answer correct, it means that either it will be 6 or 7 or 8 correct answer. So if we answer correctly of 6 questions, so he will have 8 combination 6, and if he corrects 7 questions, then it will be 8 combination 7, and if he corrects 8 questions, then it will be 8 combination 8. So 8 combination 6 means 8 factorial divided by 6 factorial, and 8 minus 6 is 2 factorial, and 8 factorial, 7 factorial and 1 factorial, 8 factorial, 8 factorial and 0 factorial, using the same formula which we have been using in all the parts of these questions. So we will have this 8, if we open this up to 6, it will be 8 7 6 factorial divided by 6 factorial 2 factorial plus 8 7 factorial 7 factorial, and this is gone, so we will just get 1 over here, right? So it will be plus 1, and this will be 28, and this will be 8 and 1, so it will be 37. So the probability of correcting at least 6 answers is equal to 37 divided by 256, right? Okay, so that was all about question number 3, and if there is anything you want to ask, or if anything which is unclear, you can ask me in the comment. I'll be happy to answer you, and thanks for watching.